Today in class, we learned how to evaluate arithmetic and geometric series. So if you'll get a graphing calculator ready, I'd like to take you through 4 examples. In this first example, we are given the beginning of a sequence. If you remember, an arithmetic sequence is a list of numbers where we're adding a consistent term to those numbers to move forward in the sequence. If you look at these numbers, you can tell that we're adding 10 to move from one number to the next. One thing that you may notice that is different between the arithmetic series and the arithmetic sequences that we looked at previously is that in a sequence, the numbers are separated by a comma because it's a list. But in a series, we are actually trying to find the sum of that list. Now, they've given me the first 4 terms, and then they have n is equal to 15. You may be thinking back, in an arithmetic sequence, when n equaled 15, we were trying to find term number 15. In a series, the n is telling me how many numbers are in the series, how many terms. So there's 15. In order to evaluate this arithmetic sequence, we are going to use an equation. It is S sub n is equal to n divided by 2 times a sub 1 plus a sub n. We can fill in several of these things with the information that was given to us. The first thing we can fill in is all of the n's. We'll put 15 in. We can also fill in the a sub 1. That's just asking for the first term, and our first term is positive 17. So we've got S sub 15 is equal to 15 divided by 2, 17 plus a sub 15. Now you may look at this and say, I can't really solve that. I still have this variable, a sub 15. What is that? Well, we learned previously that a sub 15 represents the 15th term in the arithmetic sequence. So I've got to find out what that 15th term is. To do that, we will use the arithmetic sequence equation. A sub n is equal to the first term plus the difference times n minus 1. I want to find term 15, so I will put a 15 everywhere that I see an n. I know what the first term is, 17. I also know the difference. I'm adding 10 every time I want to move forward. So, a sub 15, I need to figure out what this is. If you need to pull out a calculator, that's fine. You can do that. You've got 17 plus 10 times 15 minus 1, or 14. You get 157 for the 15th term. I can plug 157 into my equation now and solve it. Remember, when I am doing an arithmetic series, I'm looking for the sum of all 15 terms. The equation helps me do that a little bit faster. Again, if you need to pull out your calculator to actually do this calculation, that's fine. If you want to put a fraction into your calculator, you're going to use alpha y equals enter. So the sum of the 15 terms in this arithmetic sequence is 1,305. In this problem, we are given entirely different information. You may notice that I have a sigma, I do have an equation, and I've got these extra numbers. So let me explain what the parts are. The number on the bottom tells me the number of the term that I'm going to begin with, the first one. And then the number on the top tells me where I will end at term 9. If you needed to do this by hand, you would literally plug in a 1 into your equation and solve it. That gives me 6. Then I would plug in a 2. That would give me 2. Then I would plug in a 3. That would result in -2. And I would keep doing that, plugging in number by number until I get to 9. Then I would add all of these terms together, and that would give me my grand total for this arithmetic sequence. But we can actually do this a little bit easier using our calculator. If you'll pull out your calculator, you can find the sigma or summation by going to the math menu and then choosing option 0. You can see the word summation and you see the sign, sigma. We'll hit enter and we'll fill in the parts. Now you may notice they're using a variable n. I'm going to recommend that you just use the x. All right, now that you've put everything into the calculator, hit enter, and you know that the sum of these 9 terms is -90. In this problem, we're going to talk about how to evaluate a geometric series. So let me remind you, a geometric sequence is a list of terms where we're multiplying by a common ratio to move from one term to the next. A series just means that after we have that list of terms, we're going to add all of those values together and we're going to get a sum. If you look here, they've given us the first 4 terms, and we know there's only going to be 6 terms in this particular sequence because n is equal to 6. If you wanted to, you could actually find out what that common ratio is. What are they multiplying by to move forward? One of the ways that we do this is we divide backwards. 4 divided by 1 is 4, and I test that out. If I multiply 0.25 by 4, do I get 1? 1 times 4 is 4. 4 times 4 is 16. Yes. Once you know what that ratio is, you could find term number 5 and term number 6 and then just add those together. But we do have a formula for this. If you have more terms in your series, the formula is going to be easier to use. So we've got S sub n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. Now, because I have found my ratio, I already have all the parts that I need to fill out this equation. I have my n, which is 6. I know my first term is 0.25, and I know that my r is 4. Now, if you want to pull out your calculator, you can put all of this into your calculator at one time. Use alpha y equals enter to set up your fraction bar. 0.25 times 1 minus 4 raised to the 6th power divided by 1 minus 4. So the sum of these 6 terms is 341.25. In this last example, we are evaluating a geometric series where we have been given a sigma notation. Again, they're telling us we're starting with the first term and we're going to term number 8, and they've given us an equation. We'll go ahead and pull out our calculator, and we're going to go to the math menu. Go to option 0, and let's enter our information. Again, instead of trying to put a k in, just use x. This 4 raised to the k minus 1 power, all of this will go inside of the parentheses that you see here in your calculator. Now that I have it set up, I'll hit enter. The sum of these 8 terms is 21,845.